Good morning. So we're going to go over Unit 2. This is officially our Day 1 notes. The first part is a warm-up, just going over what we went over yesterday. And then we're going to talk really quickly about angles. So far, we've only talked about degrees. One revolution of a circle is 360 degrees. And now we're going to look at radians. One revolution of radians is 2 pi. So most of our radians are gonna have pi in them. So 360 degrees is equal to 2 pi. So half of 360 is 180. Half of 2 pi is just pi. And 180 divided by 2 pi, r is going to be the arc length. Remember we talked about this in circles, the arc length or length of this curved part of the circle. Span, this is the arc length. Of the radius. So this is equal to the length of the radius. Okay. And pi, 180 divided by pi, or 360 divided by 2 pi, is 1 radian. These are equal. Angle measures in degrees. If we're given angles in radians and we're trying to get it into degrees, then so we have the angle in radians. All you have to do is multiply it by the conversion. So this is going to be our conversion. 180 divided by pi. You have to multiply it by this, and then it'll give you the degrees. Okay? So if you have your radians, you multiply it by 180 over pi, and that'll give you your degrees. If you have your angle in degrees, and you want to get to radians, we're going to multiply it by the conversion. We're going to do the reciprocal of this. Pi over 180. Doesn't that make sense though? If we have our angle in degrees, that we're going to multiply, if we have it in degrees, that it's going to be pi divided by 180 so that the degrees will cancel. And if we have it in radians, there's probably going to be a pi in the top, and that will cancel with the pi in this denominator, and then my answer will be completely in degrees. We'll show you some examples. Okay. It says think about angles as a fraction of a revolution. So if a whole revolution is 2 pi, for the radians is 2 pi. So this is 0, this is 2 pi. Well, this is actually a fourth of my circle. So 2 pi times 1/4, 2 over 4 is going to give me pi over 2. So if this is pi over 2, well, this is double that, so 2 pi over 2, which is pi. And this is pi over 2, 2 pi over 2, 3 pi over 2. And then we get back to 2 pi. We know that one full revolution is 2 pi. When we look at our degrees that we need to know, remember we have to know our 30, 60, 90, 45, 45, 90 triangle. 30 degrees is pi over 6. So I'm going to draw that in here. 30 degrees in radians is pi over 6. And you can just multiply it by a conversion to make sure if you would like to. 30 is in degrees, so we're going to multiply it by pi divided by 180 because that's my conversion. I guarantee you're going to get pi over 6. 45 degrees is kind of like directly in the middle. And this is going to be pi over 4. And then we have 60 degrees. These all need degree symbols. And this is going to be pi over 3. I kind of remember that these are opposites. 30 degrees has pi over 6. And then 60 degrees has pi over 3. It's like the opposite of what you would think. But you can always check the conversion to make sure. It says converting from degrees to radius. Sorry, from radians to degrees. So we're going to multiply by our conversion. This has pi on the top, so it's already in radians. So I need to multiply it by 180 divided by pi. But doesn't that kind of make sense? Now the pi's will cancel. Pi divided by pi is 1. 180 divided by 5 is all we have to worry about. And all we have to do is, we can plug that in our calculator. 180 divided by 5 is 36 degrees. 4 pi over 9 is, this is already in radians, so we have to multiply by our conversion, 180 divided by pi. The pi's will cancel. So 4 times 180, and then divide that by pi. I know 9 goes into 180. 9 goes into 18 twice, so 180 probably 20 times. 4 times 20 is 80. Now let's do the opposite. Convert it from degrees to radians. You guys try part C. We're going to multiply it by the reciprocal. So this is going to be pi over 180. We're flipping it. This is negative 45, so my answer is going to be negative, and then it looks like pi is on the top. 45 divided by 180 is 4 on the denominator. 180 is bigger. So negative pi over 4. 150 degrees, we're going to multiply this by pi over 180. This doesn't simplify completely. You can plug this in your calculator. 150 divided by 180, enter, math, enter, enter. I believe this is 5 pi over 6, so check it out, make sure I'm right. And then you guys try 60. I know you guys remember this arc length. We went over this in circle section. So we have our reference angle. We know that this is our arc length right here, the length of our part of our circle. So not the circumference, just part of our circle. So we usually use S for arc length. So this symbol is S. And then for our radius, I'm going to use R for radius. So you can read that. Go ahead and read that. So our usual formula before we learned about radians was the degree. And this is in degrees. Okay, I'm going to put a D for degrees. Divided by 360, which is also in degrees, equals the arc length, which is usually what we need, divided by 2 pi r. You guys remember that formula? Now, I'm going to show you why we use the radians instead of degrees. So when we solve for this, we're going to get, I usually cross multiply. We usually get S equals 2 pi r times the angle in degrees. This is in degrees. Divided by 360. And I'm just going to simplify this. S equals 2 pi divided by 360 is the same as pi divided by 180 times the degree, r theta in degrees, and then times your r. But isn't the theta in degrees times pi over 180, isn't that our conversion to make it into radians? So my new arc length formula is going to be my radians, so my degree in radians, times r, my radius. So I'm going to write this. Don't forget that this is my degrees or my angle measure in radians. Okay. And this is now my new arc length formula. It's pretty easy. So a circle has a radius of 12 centimeters. So my r is 12. Find the arc length intercepted by a central angle of pi over 4 radians. It's already in radians for us. So all I have to do is plug it into my formula. S equals pi over 4 times 12. That's it. You can simplify this if you would like to. 12, you know that 4 goes into 12 3 times. So S equals 3 pi. We usually like to leave it like this in terms of pi, especially if it's a good number, like 3 centimeters. That's it. I want you guys to try the other ones. Alrighty. An angle is said to be in standard position if we're starting from the initial side, and the initial side is the positive x-axis and its vertex is in the origin. So this is going to be standard position. An angle measure is positive if the rotation is counterclockwise. So we're actually going the opposite way of a clock. So I'm going to write that down. And negative if we're going the other way, which is clockwise. So calculating coterminal angles. Two angles in standard position are said to be coterminal. If their terminal sides collide or the ending side collides. So this is 70 degrees right here. If we go around again, a whole revolution is 360 plus 70. Well, this is, I think, 430. Add them up for me. And if I go around all the way again, so we're going to go around once and then again, that this is going to be 790. Find the coterminal angles by in degrees. What we're going to add is add multiples of 360. So we're going to say theta plus 360 and then times k. We usually use k in this case. When k is an element of, it has to be an integer. It has to be a whole number, okay? And obviously this is only for degrees because I'm adding 360 degrees. If we're adding integrals of 2 pi, then it's going to be theta, if we're in radians, and it's going to be 2 pi times your k, where k is still an integer. Alrighty, now let's try 45 degrees. Let's just add 360. We want one positive and one negative angle that is coterminal. So 45 plus 360 is 315. And then they want a negative 1. So 45 negative 45 minus 360 is, I think, negative 405. Try it out. Tell me if I'm wrong. Degrees. So these are my answers. Let's try one with pi, because those are going to be more difficult. Let's try this one. 3 pi over 4 plus 2 pi? Well, I need it to have a common denominator when I'm adding fractions. So what I'm going to do is add 8 pi over 4. Because isn't 8 over 4 going to give me 2 pi? So I'm just multiplying the top and the numerator and the denominator by 4, and that would give me 8 over 4. That is 8, 9, 10, 11 pi over 4. And then if I'm subtracting 8 over 4, so 3 pi over 4 minus 8 pi over 4, this would give me, I think, negative 5 pi over 4. Okay. Determine which quadrant the terminal side lies. Okay, let's try this. So it says determine which quadrant the terminal side lies. 11 pi over 12. Oops. Okay. Oh no. I don't know why it's so crooked. So 11 pi over 12. So we're going to divide this into 12ths, basically. 12 pi over 12 is pi, so I know this is like 12 pi over 12, right? So maybe something like this. I know 6 pi over 12 is pi over 2. So 11 pi over 12 is going to be right before 12 pi over 12. So really close to pi. This is going to be 11 pi over 12. Okay? And this quadrant is the second quadrant. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and then this is quadrant 4. Let's try this one. So I'm given 5 pi over 4. So this means, 4 pi over 4 is right here, because 4 pi over 4 is just pi. This is pi right here. So this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Well, 5 pi over 4 has to be right here. 5 pi over 4. And this is quadrant 3. Usually we put a capital Q with it. So this one was quadrant 2. Quadrant 2. I want you guys to try the other ones. Actually, let's do a negative one together. So 3 pi over 4. Remember, we're still counting by pi over 4s. But this is negative, so we're going the opposite way. So this is 0. This is negative pi over 4. Negative 2 pi over 4. Negative 3 pi over 4. It's actually perfectly diagonal. This is in quadrant 3. All right, guys. This is just the introduction to the unit circle. I'm just going to go over it pretty quickly. We're going to go over it again in class, so don't think that you just have to memorize it this one time. But this is our main concept for this unit, or this part of the unit is trig and the unit circle. So our unit circle literally has a radius of 1, so 1 unit. So this radius right here is going to be 1. This value right here is your y value, right? This change in y. And this right here is going to be your x value. And this is going to be your reference angle, okay? Now sine, you guys pretty much know this. Sine is going to be opposite over hypotenuse, which is y over 1. Sine is your y values. Cosine is going to be x over 1, or adjacent over hypotenuse, which is just x. tangent is going to be opposite, right, of y over adjacent, which is x. Now these you may not be very familiar with. This is called cosecant, and cosecant is the reciprocal of sine. So instead of y, it's like 1 over sine, or 1 over y, whatever sine is. We'll usually just flip them. If sine is a fraction, like 3 over 4, we'll flip it to be 4 over 3. Cosine's reciprocal is secant. So if this is x, then secant is 1 over x. In tangents, reciprocal is called cotangent, which is x over y. If this is y over x, this is x over y. This is the signs of the trigonometric functions. What they mean is what quadrant are they positive? So let's do cosine first, since that's our x values. And this is going to be the same as secant. They're going to have the same values. They're just reciprocal. They're going to be positive when cosine's positive, secant will be positive. When cosine's negative, secant will be negative. So cosine is our x values. Which quadrants have positive x values? Well, I know my positive x-axis is over here. So my positive x-axis is over here. So I know that cosine is positive over here and over here. That means cosine is going to be negative over here and here. Now let's do sine. Or this is called cosecant. Sine reciprocal function is cosecant. And sine are my y values. So I know my positive y-axis is up here above the x-axis. So sine is going to be positive up here and up here. And that means that they're going to be negative down here. Now let's look at tangent. And cotangent. Oops. Okay. Well, tangent is going to be, it says y over x. It's actually going to be sine divided by cosine also. So sine divided by cosine, positive divided by a positive is a positive, but a positive divided by a negative is a negative. A negative divided by a negative is a positive. And then a negative divided by a positive is a negative. Okay, so that's going to be the signs for tangent and cotangent. Which quadrant is sine less than 0? So where is sine negative and cosine less than 0? Where are sine and cosine both negative? So sine is negative in quadrant 3 and 4. Cosine is negative in quadrant 2 and 3. So they're both negative in quadrant, let's write it Q3. That's it. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And we use the Roman numerals to find it. You guys can try the next one. Alrighty, let's try this. It says, determine the sine if the given trigonometric function for the angle, or of the given trigonometric function for the angle provided. So what is cotangent at 17 pi over 6? So I need to know where 17 pi over 6 is. I know that 6 goes into 12. So 12 pi over 6 would be 2 pi. So we're going to go around again. So let's subtract 12 pi over 6 and find my reference angle. Subtracting 12 pi over 6 is going to give me 5 pi over 6. Okay, I can find this. This is going to be pi over 6 2 pi over 6, 3 pi over 6, 4 pi over 6. Ooh, 5 pi over 6 is right here. So I'm going to make it red. Because 6 pi over 6 is at pi. So I know it's right before pi. Okay, and they're just asking us what quadrant it is. So this is quadrant 2, and they're asking us the sign. In quadrant 2, cotangent is negative. So that's the sign, negative. Given one trigonometric function, find the other 5 trig ratios. This is something they're going to ask us to do often. Sine of 2 over 3. Let's say it's in quadrant 1. Because it could be in a different quadrant. We're going to say it's in quadrant 1. So sine is the opposite over hypotenuse. So my opposite side is 2, and my hypotenuse is 3. And we really have to find this other side to figure out the other ones. So I have to use Pythagorean theorem. So 2 squared plus whatever this side is squared has to be the hypotenuse squared. 3 squared is 9, 2 squared is 4. This will give me x squared equals, so it's going to be x equals square root of 5. Probably. Alrighty, so this is the square root of 5. I need this so I can find out the other ratios. If sine is 2 over 3, cosecant is 3 over 2. We're just going to flip it. Cosine is the adjacent over hypotenuse. My adjacent side is square root of 5 over my hypotenuse, which is 3. And secant is the reciprocal of that. Tangent is opposite over adjacent. So I'm going to write it O over A. Sorry, that's A. So opposite is 2 over adjacent, which is the square root of 5. Cotangent is just the reciprocal of that. And we really can't leave the square root of 5 in the denominator. We have to multiply the top and the bottom by the square root of 5 to rationalize it. I want you guys to try out the rest and ask me if you have any questions. I'll see you in class.